would only cost about $250 to write it out on goat skin.
I'm down. But if we're gonna spend $250 on goat skin, I better get Leviticus.
Oh no, that's for Revelation.
That's fine. That's fine. I better get a handwritten revelation on goat skin.
Oh yeah, if you buy it, I will write it.
if I'm getting like a legit commitment. Yeah.
Some person goat skin.
Hang on, does it need to be like good handwriting or can it just be crappy handwriting?
Some person. No, I'm gonna posted what? I'm gonna use a.
How many questions do you have left?
Yeah.
Well, a lot.
No. All right. Yeah. Shut up. We're missing a bunch of people, aren't we?
Yes, Blaine.
That's just one person. All right, let's go. So did our occurs free work? Our occurs bound work? Because I don't think we quite tested it at the end of class last time, right? It didn't work?
No.
Well, you didn't test it.
Well, I tried to test it. I don't know how to test it.
Hold on. Okay, hold on. You said you don't know how to test it. It takes in an expression. What's an expression? What are our three forms of expression? I feel like I said it 20, 30,000 times last class. What are my three forms of an LC expression?
Was it like var expression?
Var expression, lambda expression, app expression. So you need to give it an expression that fits one of those forms, as well as a symbol we're looking for. So I can say define an expression to be, now we have to give it to it in list format. So let's say we'll take in a lambda, and our lambdas can only take in a single value, right? So we can say A, and then we can pass in an A, and say we're searching for, well, actually, I need to call it. So that's my expression I'm going to test. And then we'll call occurs bound on exp and a variable named A. So here's an example expression. We want to know if a variable named A occurs bound in there. We have a binding, and here is an example of it occurring within the scope of that binding. So this should give us a true. Oh, it's called EXPR.
There's just an extra on that one, it looks like.
Somebody was supposed to be in charge of my spelling. All right, there's my true. That A does occur bound in that one. And if I say, does C occur bound in that one, I should find it to be false. And if I say, does A so that's a lambda calculus expression, right? Mm-hmm. So here's a lambda expression that takes a single parameter, and its body is a lambda calculus expression, which is an app expression. So I'm asking, does C occur bound in that expression? It does occur, but it does not occur bound, so it should give us a false. Make sense? All right, so now I need to know why you didn't know how to test it. Because we have several heavy things around I can throw.
It's been a long week.
So you need to use the constructors or format the way you did it.
Oh, I don't care. I just formatted it that way. Do we have constructors for these guys?
Yeah, we should have made them beforehand.
Oh, we did, yeah. So technically you should have built your thing as a, what's our constructor for lambda?
Lambda-exp.
Lambda-exp, and this guy takes in a symbol and a lambda calculus expression. We're going to give it an app exp. Mm-hmm. And that guy takes in two symbols. This is a function. There's my symbol. And this guy just takes in two symbols, so I have an A and a C.
Yeah.
All right. So this produces, if I just print out EXPR, it should give us our, effectively what we just wrote. Yeah. All right, so same thing, but this uses the constructors that we built, so we're not wasting our time. So this is more correct. All right. So two issues. One issue is it's not a valid excuse to say I didn't know how to test it when I also didn't see a question saying how do we test it on Slack. So if you don't know how to do something, there has to be a question that occurs as a result of that. Make sense? All right. Otherwise, because I mean, I don't even know how you could have gotten much out of your assignment if you didn't know how to test the occurs bound we wrote. How did you test the occurs free that you were supposed to write? Yeah, I'm looking at you, Luke. And who else said they didn't know how to test it? Who wants to admit to it now? Nobody's admitting to it now. It's like, look, the damage is done. All right. Does it make sense how to test it now? For those of you that were confused. I mean, we did give it variable names that were meaningful and we're really drilling home. And I mean, it really is important at this point. I mean, I'm kind of jokingly, yelling at you, but, it's important at this point when we look at our book. I know the book is, where's my book? Do I have it in a different, is it in preview? No, that's me. This seems dangerous. This seems very dangerous to just keep randomly opening things.
Might end up finding.
Gosh, do you have any
You're looking
that on your
Looking for the textbook.
Do you even remember what the file was called?
EOPL something or other.
Yeah,
Why can't you just spotlight it?
Yeah.
There you go. All right, so we are going to spend the rest of this semester working with grammars and productions. All right, so this whole thing as a whole is called a grammar. This is the grammar for a lambda calculus expression. All right, and forget about the scariness of lambda calculus expressions, just that name. Okay, this could be the grammar for defining the language of cats. All right, so a grammar defines a language. Each of these lines in here is a production within this language. That is one of the versions, one of the things that matches that language. So in our current definition here, we have 3 productions that each match the definition, the grammar of LC expressions. The first one is something that is just an identifier. We've named that a var expression. The next one is a list containing a lambda, containing a list, containing a single identifier, closing parenthesis, followed by a lambda calculus expression. So we would say that this production is recursively defined. That is to say we have hard-coded stuff here, but then this guy here can be anything that meets the criteria of this grammar. Our third production is a list containing, this is again a recursively defined production. It's a list containing anything that meets this grammar, as well as another anything that meets this grammar. Make sense? So we have a function called occurs bound that's taking in an expression, any expression, that is anything, as simple or as complex as it might be, that matches the grammar for LC expression. So I can pass occurs bound the var exp a, like that. That is my first production of my grammar. So that is just the symbol A. It gives me a false. What if I did this? What's the output of that going to be?
False.
Anybody think it's true? Where do bindings occur? It is false. This will be false. Where is the only place a binding can occur?
In a lambda expression.
In a lambda expression. So in our second production, this dude, this is the only production that supports bindings. Bindings occur right there. That's a parameter coming into a function. All right, so that's where we're binding an identifier. Now, just because we bind an identifier doesn't mean that that identifier occurs bound. It just means that it is bound. I then need to check to see if it occurs at all. Make sense? I thought we decided you're out of questions.
No, but it's that different topic.
All right.
So like on your slide the other day,
Yeah.
there was an example that you give for like lambda x and then lambda y and then x and z.
Mm-hmm.
You say x is a curve free, z is a no, x a curve bound, z a curve free. How about y?
Okay. So let's go. You're saying I have a example in my slides.
Is that one of the things I bumped into yesterday? Like
What, this one?
yeah, like the second one. So you have x is a curve bound, z is a curve free.
So X is bound right here,
yeah. So how about y?
and this is where it occurs. Z occurs free because Z is not bound here and it's not bound here.
How about y?
Y is bound, but it does not occur.
So then it's none of the above.
That's false.
Yeah, it would be for occurs bound. Y is occurs free or occurs bound. Y is false because it does not occur. Yeah, so we have two bindings here: a binding for X and a binding for Y. But bindings don't mean anything unless you actually use that variable. It's an untapped resource. So we're checking to see whether a particular variable occurs inside of a variable scope where it was bound. That's what we're checking here. That's the connection we're making. We built a variable environment, right? And now we're practicing using, now we're seeing the language side of things of where variables get bound and being able to determine whether something is bound, because what would be the next logical step? If I bump into a symbol and I determine that that symbol is bound, what does that mean I should be able to do? Well, that's what occurs free and occurs bound do. I'm talking, what's the next step in our evolution of our language? We have a variable environment, which holds name value pairs, right? Mm-hmm. Now I have something that's able to go through a lambda calculus expression and determine whether, if I give it a variable name, whether that guy occurs bound. So if I find a variable name that occurs bound in there, what should that mean in the next step? What should I be able to do with that variable name? Go ahead.
Like resolve it?
Yeah, get its value. We should be able to look it up in the environment. Because if it's bound, presumably it now has a name value pair in the environment one way or another. So that means when I run into that guy, I could say, hey, give me the value of C. Give me the value of A. So I can do mathy stuff with it or whatever. If it doesn't occur bound, then that means it might not occur. But if it occurs free, that means I have a variable that does not have a value, which may be problematic. Not necessarily problematic, it depends what I'm trying to accomplish. But I could have a symbol that does not occur bound anywhere, which means that it must just be a literal symbol, or it's a variable I forgot to define. Something like that. Go ahead.
Maybe I'm just getting confused. Occurs free also is the case when it's not a lambda expression, or only when it's lambda expression but not?
In our world right now, it's only in our lambda expressions because that's the only place. Well, occurs free and occurs bound. Let's just define these guys. Occurs free, occurs bound. This guy returns true if a variable we are searching for occurs and was not bound. And false otherwise. Occurs bound returns true if a variable we are searching for occurs and was bound, and false otherwise. So first and foremost, whatever we're searching for has to occur somewhere. Keeping in mind that if I'm looking for, let's operate off of our example slides here. If I'm operating off of this slide, for example, x in this lambda calculus expression right here, does x occur? It does not. Why not? Why does x not occur, Luke?
Because it wasn't used.
Well, what's this?
That's declaring.
That's a binding.
Yeah.
Yep, that's a binding. The things that are inside of our bindings do not count as that thing being used. That's where bindings occur. Used in a lambda would be somewhere out over here in the body. Now, having said that, what if I had lambda x, lambda x, lambda x, y? Does x occur?
No. Each one of those is a different declaration.
Each of them is a binding. Every time we see an x in there, we are seeing it as part of the parameter coming into a lambda. That does not, things can't occur there. That's where bindings happen. Okay, where a binding is a parameter being passed in to a function, giving us a binding for a local variable. All right, so only if we had put an x there, for example, does x now occur. We have, in this expression here, we have a binding for x, a binding for x, a binding for x, and then an occurrence for x. And this occurrence, so x does occur bound, specifically it's bound to its most local scope. If you want to connect this back to Java, a variable always resolves to its most local definition. All right, so this x is bound to this x right here. If I change this to a y, now this x is bound to this guy right here. If I change this to a z, now this x is bound to this x right here. If I change this to an a, now this x occurs free. It's no longer bound by any of my bindings. I have a binding for a binding for z, a binding for y. X occurs, but it doesn't occur bound. It occurs free. So if we look back at what I wrote on this slide here, notice I have occurs in both of these. We will always return false if the thing we're looking for does not occur. If it's not in there, we have nothing to look up. We have nothing to try to resolve. We have nothing to, it doesn't occur. I mean, you could search for whatever you want, right? But if it's not in there, it's not in there. All right, so before everything else, it has to occur. So what we try to do is we look for bindings to find out what might be bound, and then we check to see does something occur inside of that scope. All right, does that make sense? The difference between occurs free and occurs bound? Is that clear? All right. Okay, and again, if things like this are confusing, ask questions. I could have made a quick little video or something like that and thrown it up on Slack, just basically going over this slide if there was confusion as what is occurs free versus occurs bound. Okay. So homework was to write occurs free, correct? We already wrote occurs bound?
Yep.
All right. So we're gonna define occurs. Did I spell it right? Is there 5 R's?
Yeah.
Yes. Yes, there is. All right, so this guy's going to take in an expression and a symbol. What did I call a var name up there or something like that? Yes. Okay. All right. So we all know how we can call this one now? Pass it a lambda calculus expression and pass it a symbol we're searching for. All right, so what's extra bad is that we specifically choose meaningful. I mean, like it would have been, more acceptable if we had like an LOL and like, I don't know, like a smiley face or something like that. Is your, what is this, just a dude with eyes and a mustache? So, or that's saber-toothed tiger.
It's been a long week.
Yeah. All right. So we have occurs free. We're taking these two things. Well, right off the bat, we have our productions. We start seeing our patterns here. If we look up at occurs bound, we see in our cond, we see var expression, lambda expression, app expression. So we are seeing our grammar spelled out in scheme. Again, this is one of the reasons we use scheme in here. All right, because you could actually just see it play out in it's a list version of our grammar. All right, so we'll do a cond here. And every single time when we're doing this, we want to ask the question in the context of the current time through. This is where we're starting to get ourselves to start thinking recursively. Remember at the beginning of the semester, I gave you this warning that most of us come into this class not being necessarily strong at recursion. Recursion is usually something that takes some time to wrap your mind around. By the time you come out of this class, you should be really good at recursion to the point that you might have some difficulty going back and thinking about problems iteratively. It's like, look, what's a loop? I'm not familiar with that type of thing. All right, so if my expression, did I use our testers? Do we have predicates for those?
Yes, we do have predicates for
But I didn't use them on my other thing, right?
I thought you did.
Did I?
Do you not? Oh, you should have.
Yeah, let's use them in this one. So if what I'm looking at is a var expression, is that what my predicate's called? Mm-hmm. So if my expression is a var expression, I wrote that above apparently a couple classes ago maybe. Okay, if that guy's a var expression, what am I going to do? All I know is that I have a variable that occurs at this point. I see a variable. This is not a binding. So as far as I'm concerned, what can I do? Go ahead.
See if it's the right variable.
Okay, what if it is the right variable?
Then you return true.
So I am interested if it's the right variable. Go ahead.
Well, if the expression is just a variable expression, then we can just compare the symbol that is our expression and the symbol we're checking for and return the result of that
Let's look at this.
result.
Let's say I'm on my recursive call right here. So let's say I'm looking for A. Okay, I know that A is occurs right there, correct?
Mm-hmm.
But my original call to occurs free is going to be in this whole thing.
Mm-hmm.
Then I'm going to hit a binding for X. Now, at some point, I might call occurs free on this guy.
Mm-hmm.
But if I'm just asking if A occurs free on what I have highlighted there, that is a lambda calculus expression, correct? If that's my whole world is right there, that's this recursive call, what can I say about A occurring free?
True.
Does it occur? Well, does it occur free? Is it bound there? I don't see any binding. Okay, so as far as I'm concerned, I found something here, and in my world, The thing I found occurs free. Because I'm not dealing with a binding at all, right? So this guy would boil down to a true. Make sense?
Don't we have to check and see if it is S though?
Why?
Because right now we're just saying that if we find something.
Yeah, my something here is not bound, but if is it the thing that I'm searching for? Otherwise, I might be searching for an A, and I just return true that, yeah, A returns occurs free, but in actuality, it doesn't occur.
Does A occur free in the expression X?
Yeah, so we would return EQ of S and EXP. I hear him talking about me down there. All right, so if I'm looking at a var expression, as far as I'm concerned, the thing that I'm looking at occurs free. But I'm supposed to be returning my answer for occurs free based on the thing I'm searching for. So I know this guy occurs free. I want to return true if the thing that occurs free is the same thing I'm looking for. Make sense? All right, so that's our first production. Now again, we're thinking about this in terms of our current run through here. Next, I'm looking at a lambda expression. If that's the kind of dude that we're dealing with, is a lambda expression. Now I know that I have a binding. Correct? So what I care about is I want to make sure that my binding is not the thing that I'm trying to find out if it occurs free or occurs bound. Right? And so, I found something. So if we go back to our example here, so we're looking at a lambda here. I just ran into this X. I have a binding now for X. Now, if X matches the thing I'm searching for, now what do? Go back to our thing here. Occurs free returns true if a variable we are searching for occurs and was not bound. I just found a binding, correct? But now I only care about that binding if relative to the thing I'm searching for. So what's one possibility? If my binding matches the thing that I am looking for, I need to know whether or not it occurs. The thing I'm looking for occurs in the rest of it. Because occurs free requires that it first occur. Secondarily, it requires that it's not bound. Okay? So if I'm looking at a lambda expression, what do I want to do in this? I want to find out what my binding is, right? So we can do it as in a let if we want. So we'll say let, and let's get our bound var. Our bound var is going to be equal to, did I have deconstructors to grab pieces?
No. I don't think so.
Schoolboy error. All right, so this is going to be the CAADR of EXP, the car of the coder. All right, so that will get me my variable that is being bound. All right, and then I'm going to get the body, which will be the CADDR. So I have my two pieces there, right? So now in the body of my let, what I care about is if the binding I just found, if that guy is equal to the variable I'm looking for, if S occurs inside of the body, then it would be false. It does not occur free. Because if it occurs in body, it occurs bound because it's bound right here. Make sense? So we'll ask a question here. We'll say, if EQ bound var and S. If the thing I'm looking at, if the binding I'm looking at is equal to the variable I'm searching for, then I know I have a binding for it. Now I care about whether or not it occurs. If it occurs, I should return false. If it doesn't occur, I should return what? False. So what do I do? Just return false. Now what if it's not equal? No harm done at this point, right? So I call occurs free on the body, passing it the same S. I have no binding. I just blew past this lambda expression. Didn't hurt anything, right? Okay, just keep trucking. All right, so that's what we do for lambda expressions. Last one is my var expression, or my app expression, sorry. So we'll just do that inside of an else. So I'm dealing with an app expression. Now, app expression, I want to return occurs free on either of the two sides, right? So I'm going to or occurs free on the car of EXP and occurs free on the catter of EXP. So that should be occurs free. How come we never used occur? Nowhere in here did I check to see if it actually occurred. Well, I never called occurs. Could I have a called occurs somewhere? Is this effectively a call to occurs? It's the only case that matters, right? Because this is where things occur. Things occur in var expressions in our current language, right? So I can make a call to my function called occurs, which would give me a true if these two things matched. But in this case, I just said, look, if I'm looking at the same thing, yes, it occurs. But did it occur based on a binding? Who knows? All right. So this should be occurs free. So we have our expression. Lambda expression takes in an A. App expression. So C would occur free here, right? So we'll call free on my expression, passing it C. Oh, I didn't. Whose job is this one? To make sure I pass in the. Is that your job, Lane?
No, it's these.
B?
I'm spelling it.
These have questions, so no. We cannot talk about this.
That's not a question.
So C does occur free in there, but A also occurs, but it occurs bound. So let's check against A. So A should return false for occurs free because it occurs, but it occurs bound. And then I can do a, well, I guess we already tested the other case. I can test for a Z. A Z doesn't even occur. So for occurs free, it should also return a false.
Hang on. Why is A is occur free is a false again?
So A, because A is bound right here,
Oh.
and it does occur. So since it occurs, we ask the question, does it occur free or does it occur bound? It occurs bound because it's bound right there. Therefore, if I'm asking whether it occurs free, the answer is no, false. It does not occur free. It actually occurs bound. Where if I'm searching for a Z, for example, Z is not bound anywhere, but he also doesn't occur anywhere. So as soon as I determine that he didn't even occur, I'm just going to return false. I never even found him. I don't care if he had a binding. He wasn't there. He didn't occur anything. So that's a false. Go ahead.
When you're declaring the expression right there,
Mm-hmm.
that's another form of binding, right?
No. You could have, an app expression is a lambda calculus expression and a lambda calculus expression. So I could have a binding in here. I could have this guy be a lambda exp z, something like that. And now I do have a second binding, but my bindings are always associated with lambdas. So this app expression does contain a binding, but it only contains a binding because one of his two lambda calculus expressions is a lambda expression, which has a binding.
So C should occur free then.
C occurred free whether I put this in there or not.
Right. I'm just asking because.
Did you say C or did you say Z?
C.
C. Yeah, C definitely occurs, right? We see it occurring right there. Okay, it occurs. Do you see it bound anywhere? Is it bound? We have two places for binding. We have a binding here, and we have a binding here. Neither of those say C, therefore C occurs free because it is not bound.
Right, that's what I thought. It just is returning false for me, so that's why I asked.
All right. Questions about that? All right. That's that data type thing I told you last time that I don't like using.
The arrows?
Yeah. We just did a bunch of occurs free stuff. So we're going to keep going. I think this should take us through the rest of... All right, I'm just going to talk about this real quick. So they have this thing called parse expression where I'm avoiding the data type version of this just so we can stick with scheme and get farther into the language stuff. So they have this thing called parse expression that allows you to move in between the data type version and the string and list version. Just to kind of, you have parse and you have unparse. So it allows you to write it one way and automatically turn it into the other one, or write it in the other way and automatically turn it into the other one. And that's only important if you happen to want to write it one way as a human and then get it into like data type format. So if as a human being you like writing the lambda as lists and things like that, like write normal scheme, but then you want to convert that into your data type version, which we're not using, then you would use parse. All right, we're not doing that. All right, so parse and unparse, that's what they are. They're converters that we're not going to need to use because we're writing it in the same format as we're using it. Okay, so now our next step is what if we expand our definition of lambda to take 0 or more parameters. So this initial pass on this said it takes in exactly one parameter, right? So what would change in occurs free and occurs bound if my lambda, this is my new grammar for a lambda expression. So we have a var expression that just is an identifier. We have a lambda expression that is the word lambda followed by opening parenthesis followed by, so we got this thing called Kleene star, okay, which is a fancy way of saying 0 or more. All right, so this is a list containing 0 or more identifiers. That's what that says. So again, a lambda is an unnamed function. When you write functions in Java, you can have a function that takes no parameters. You can have a function that takes 9 parameters, right? This now defines that idea, is that we have a function, that's what a lambda is, that always has a parameter list, so it'll always have an open and closing parentheses, even if it has 0 parameters in there, but now he can take any number of bindings. Make sense? Not exactly one. So up to this point, we've wrote occurs bound and occurs free in terms of a single binding. Exactly a single binding. So now we want to rewrite those guys in terms of a potential multiple bindings, where I should be able to write something like this, where I have lambda x, y, z, a, x, z, like that. So this is a lambda that takes in 3 parameters. His body is a lambda calculus expression. It is an app expression whose first element is a var expression, whose second element is an app expression, whose first element is a var expression, whose second element is a var expression. So in this case, x occurs bound, z occurs bound, a occurs free. Make sense? So now you need to update occurs bound and occurs free to work for 0 or more parameters in a binding. Make sense what you're trying to accomplish?
Yeah, say it again a different way.
Say it again a different way. Before, here, let's do it this. I'm going to write this. Say assignment. Old assignment only worked for lambda x ax, things like that, where the parameter list for your lambda had exactly one thing in it. New assignment should work for lambda x ax, should still work for that. Lambda ax, no inputs. Lambda abc a b cx, things like that. So this stuff already works. If I just take this and I put it up here for our current one, it'll still work. We didn't change. We've only changed one production of our grammar. We changed the lambda expression production, where a lambda no longer is exactly one identifier for a parameter, for a binding. Now it is 0 or more parameters for a binding. So you need to update occurs free and occurs bound in terms of a lambda expression production that supports 0 or more parameters.
You answered my question.
Got it? All right, because if I had passed this guy into my current occurs free and occurs bound, well, I'm going to actually get an error because I'm going to try to take the car of that guy. I take what? The car of the critter, and it's going to scream at me and say, that dude don't got a car. It's an empty list. Empty lists don't have cars. All right, so don't try to. They don't have a license. It's the get it. Haha. All right, so my current one would not work for 0 parameters. My current one would not work for 3 parameters. It only works for exactly 1 parameter. So my current production for lambda calculus expression says exactly one binding. My updated definition says we could have 0 or more bindings. So homework is update occurs free and occurs bound to support a lambda expression where there are 0 or more identifiers, say bindings. None of the other productions changed. A var expression is still a single var, single symbol, and an app expression is still 2 lambda calculus expressions. So only one of our productions shifted. Which means what? In our current version of occurs free and occurs bound, should we have to change those 2 productions?
No.
We should only have to make changes in the production that shifted. Questions, comments, concerns, bribes? I'll put the current code up on Slack.
Oh my god. My weekend.
Why? This is not going to be that bad.
You got it. You got it.
That's what I said. Just
Remember, you have to understand the problem you're solving, including how you will test it and call it, before you can solve it. So make sure you sit down and try to understand the problem, walk through, and decide how do you need to update your production. This isn't that big of a deal. This is not a huge, crazy assignment. But you need to start telling yourself you have to slow down and make sure you understand what you're being asked first before you can just start writing random scheme.
What I find helps with that is just to leave a comment that tells me what I'm doing. And if I can't do that, I don't know what I'm doing.